All right, this is lesson 5.2, and this will be the first video. There'll be a couple of videos that explain this lesson. And it's basically lesson 5.2 is kind of a continuation of 5.1. We're going to use those fundamental identities again and basically take trig functions that look complicated and somehow try to make them simpler. And so our main idea here is, can you rewrite a trig function? And if it looks complicated, can you make it look simpler? In the book, if you look on page 195, it's going to outline a method. And sometimes when you have these methods, it's not quite as easy as it sounds like. So I'll give you this method, but it's really going to take practice to get a handle on it. First thing it says is you have to know your fundamental identities. We talked about those in section 1. If you forgot those, look at the very end of your packet. So it'll be the very last page in your packet. We've got them listed again. And you might remember we also had those negative angle identities. Those don't come up as much. But these three sets, the reciprocal identities, the quotient identities, and the Pythagorean identities, you'll want to know these three sets off the top of your head. They come up very, very frequently, and you'll want to just have these memorized. So when you see tangent, you immediately think, ooh, 1 over cotangent. Or you think sine over cosine. But those things just become automatic as we're working through these problems. Okay, so that's a suggestion that's made. And then following through with this, what else? If you want to simplify something, if there's an equation, start on the complicated side of the equation and try to make the complicated side simpler. A lot of times it's nice if you can get sines and cosines. It's a lot easier to work with that. In the first lesson, that's what they wanted. They wanted things in terms of sines and cosines. You might be asked to factor. We'll go over a factoring problem or two, so it's a good thing to remember if you've forgotten it. And then the other thing is these are open-ended questions. So if you try a certain method and it doesn't work, you just have to try something else. So it's open-ended. I can't give you one strategy that works every single time. Every now and then you use the Pythagorean identities, maybe the reciprocal identities, maybe all sorts of identities. And there's no tried and true method that works every single time with those. There's certain things you'll look for and things that work frequently or things you want to think about, but you want to be open. If your method doesn't work, try something else. Okay, there's going to be all sorts of problems on the homework, different variations. One type of problem is going to say something like this. Perform the indicated operation, and then simplify. Well, here in this problem, the indicated operation is adding. And again, good practice. Do you know how to add fractions? Sure. Get a common denominator. So we've got a sine, we've got a cosine. So our common denominator has to be both, sine and cosine. The first fraction, it already had the sine on it, so I have to multiply top and bottom by cosine, and that first fraction becomes cosine squared over sine cosine. Second fraction, it already had a cosine in the bottom, so I have to multiply top and bottom by sine, but I already had a sine on top, so now I've got sine squared. Add these up, and I've got my common denominator, so I've got sine and cosine. And at the top, I add up the tops, and I get cosine squared plus sine squared. And at this point is where you want to be very familiar with those fundamental identities. If you're not familiar with them, let's just take that away, actually. If you're not familiar with those, let's just look again and see. Again, there's the last page. Oops, went a little too far. The last page of your packet here. And you might notice, here's an identity for sine squared plus cosine squared. That's the same thing as 1. So if you recognize that, you can take an expression that still looks kind of complicated, and we can make it simpler, because look at that. Cosine squared plus sine squared, the top of this, that identity says that's the same thing as 1. So I'm going to write this as 1 over sine cosine. And this is a perfectly legitimate answer, 1 over sine times cosine, because I prefer that you leave answers with sines and cosines in it. You may check it in the back of the book, and 1 over sine is the same thing as cosecant, and 1 over cosine is the same thing as secant. So they may write it like cosecant, secant, but I kind of prefer this answer here, 1 over sine times cosine. They're identical, and in terms of which one's simpler, they're kind of equally simple or equally complicated. All right. Let's try another one. 1 plus tangent, the whole thing squared, minus 2 tangent of theta. And again, you see that square. Hopefully you think of the Pythagorean identities. Before we do that, though, let's FOIL out this first one. So 1 plus tangent of theta squared means 1 plus tangent of theta times 1 plus tangent of theta. And we still have over here this minus 2 tangent of theta. So let's FOIL this out. First gives me 1. Outside and inside give me 2 tangent of theta. And the last I get tangent squared of theta. And I have over here minus my 2 tangent of theta. I'm looking, could I combine like terms? Does anything cancel out? And sure enough, 2 tangent minus 2 tangent cancels out. And I'm left with 1 plus the tangent squared of theta. And again, you have that squared on a trig function. You're thinking of those Pythagorean identities. Do you know this one off the top of your head? 1 plus tangent squared. Do you have these memorized yet? Look at that. 1 plus tangent squared. Right there. 1 plus tangent squared is the same thing as secant squared. So let's come back. 1 plus tangent squared is the same thing as secant squared. So I could leave this answer as secant squared of theta, or secant is reciprocal of cosine if you want to leave cosines in your answer. So either one of these is a perfectly acceptable answer. And you can't really make it any simpler than that. When you get it down to a single trig function, that's as simple as you'll ever be able to make it. All right, kind of fun. Let's do a couple more. Now what they'll do is they'll switch the directions on you, and we're just practicing algebra skills. And they're going to practice here. Do you guys remember how to factor? And maybe with a trig function there it's a little confusing, but if instead of a trig function, if I just gave you x squared minus 1, hopefully you wouldn't hesitate. You'd say, oh, that's the difference of 2 squares. And that factors into x minus 1 and x plus 1. So over here, the sine squared of alpha minus 1, when I say factor it, well, it's going to be the sine of alpha minus 1 and the sine of alpha plus 1. We won't FOIL that back out because we'll get back where we started. And since the directions said factor, we're just going to do what they told us to do. We'll just factor it. Nice practice, but you know, you can argue, was that simpler? Could I have done something else with that? But since they said factor, we factored, and that's our answer. Let's try this again. 2 cosine squared x plus 3 cosine x plus 1. And again, maybe that looks weird. So let's just go 2x squared plus 3x plus 1. Could we factor that? And there's different ways to factor. A way that people have been commonly taught now is the AC method, where I multiply the first and last coefficients, the 2 and the 1, and that gives me a 2. Then I want to break up the 2. There's not a lot of ways to break it up. And I'll break it up into 1 times 2 because 1 plus 2 equals 3, that number right there. Then I rewrite this as 2x squared plus 1x plus 2x plus 1. And then you group the first 2 and you group the second 2. The first 2, what do they have in common? They have an x in common. Second 2, what do they have in common? Nothing. So factor out a 1, leave it alone. And after you do that, you look at the terms and realize they both have a 2x plus 1 in common. So I can factor this into a 2x plus 1. And I pull that out. What's left? The x and the 1. And I factored it. Okay, having done that, now I look at this problem, and it's exactly analogous, except playing the role of x. And this problem is now the cosine of x. So I could go through the same exact thing, or why don't I just use the answer from on the right side there. Instead of 2x, I'll write 2 cosine of x plus 1. Instead of x plus 1, I'll write cosine of x plus 1. So we'll take the factoring that you already knew how to do, we'll leverage that and use that now to factor problems that are very similar, but instead of an x, we had a cosine squared. Or instead of x squared, we had cosine squared. And we just treat that cosine just as if we would have treated the x. All right, that's actually not a bad place to stop the first video. So we'll pause that, and then we'll continue with more.